Hello everyone, my name is Archit Agarwal and my registration number is 20 BCE 1773, and the topic I've chosen for my digital assignment 3 is the study on the Turing machine and its applications. So coming to the introduction part, the Turing machine was introduced by Alan Turing in the year 1936, and it is considered more of a model than a machine. Its main attempt is to define it an abstract machine through an algorithm that enables it to simulate any algorithm logic, whether it be simple or complicated. Now, coming to the definition part, a Turing machine is basically a finite state machine with an infinite tape and a tape head that can read or write one tape cell and move either left or right. Now, each tape cell consists of an input symbol or a special symbol called the blank symbol, and a tuning machine normally accepts the input string and completes its computation by entering a final or accepting state. Now, how is a Turing machine represented? It is basically represented by a 7-set tuple as shown, where Q is the finite number of states, T is the tape alphabet, that is the symbols can be that is the symbol that can be written on the tape. B is the blank symbol. Initially, every cell is filled with the blank symbol except the input alphabet. Summation is all the input alphabets, and theta is the transition function which maps Q multiplied by T tends to Q multiplied by T multiplied by left or right. What does it mean? Basically, it means it means that depending on the present date and the present tape alphabet, which is pointed by the head pointer, it will move to a new state. May or may not change the tape symbol, and it will move the head pointer to either left or right. Q naught is basically the initial state, and F is the set of final states. If F is reached, the input string is accepted. Now, here we will go to a basic Turing machine model. As we can see, this is the head pointer which points to a specific tape cell. X1 and X2 would here be the input symbols. B here represents the blank symbol, and the tape of infinite length has been shown here. Now coming to the variations of Turing machine, there are many variations as listed below, like multi-tape Turing machine, a non-deterministic Turing machine, a multi-hit Turing machine, offline Turing machine, and a multi-dimensional Turing machine. Now coming to the applications, the first application would be of check decidability. So what does it mean? Now, if a Turing machine cannot solve a problem in a countable time, then there could not be any algorithm which could solve that problem. That is, the problem is basically undecidable. Now, if the decision problem falls in a countable time for all length inputs, then we can say that the problem could be solved by any algorithm in that countable time. Coming to the next application, classifying problems. Turing machine helps to classify decidable problems into classes of polynomial hierarchy. Now, supposing we find out that the problem is decidable, then our target becomes how efficiently we can solve it. Now, the efficiency is calculated in number of steps, length of the code, size of the final state machine, and so on. Now, the final application would be the designing and implementing the algorithm for practical machines. Turing machine helps to propagate the idea of the algorithm in other practical machines, and after the successful check of one or two criteria, we can use our practical devices, computers, to design and implement the said algorithm. Here, I would like to end my presentation. Thank you.